Hello guys, welcome to this wonderful course. The title of the course is Statistics for Geomatics and Surveying, and the course code is EGS 3201, and your instructors will be Mr. Ndovu, me, and Mr. Aramon. So those are the two people responsible for the teaching and learning of this course. Welcome once again to this online Google Classroom. Right, so what will this course cover? Right, so first we're going to look at introduction. So I'm going to introduce the course and then look at some statistical hypotheses behind geostatistics, and then we look at the foundation of geostatistics, which is the variogram. It shows the distribution of spatial data, and then we also look at the kriging methods, the ordinary kriging for interpolation, data interpolation, or predicting values between points. If time permits, we also going to cover multivariate analysis, because when we are doing survey there are a lot of variables that we need to consider and analyze. Right, so what is geostatistics? So geostatistics is a class of statistics which is involved with the analyzing of data, which is also involved with prediction of data with regards to spatial or spatio-temporal phenomena. So if you have got a data which is distributed within different coordinates or between different 2 points, or you are measuring some variables within a surface and you want to analyze that data, we apply geostatistics. So the geo part is the geography, which is the location, and then we applying statistical tools in analyzing these spatial types of data. So geostatistics is a very useful tool in interpolating values for location, so interpolating and predicting values between 2 points. Suppose you have values between 2 or 4 blocks, and then you want to interpolate the other block which is in the middle of those two. You can then try to use geostatistics to interpolate, find values between points. So the mining industry uses geostatistics for several aspects of projects. So initially to quantify mineral resources, to evaluate project economic feasibility, to determine where to drill, to determine reservoir estimation, to predict all those, and then also to determine the continuity and lifespan of a mine. So, but most recently, geostatistical tools have also found application in soil sciences, in agriculture, and the recent one we have seen it being applied in this pandemic to determine the incidences rate and hotspots for COVID-19. Alright, so one of the very key concepts that is there in geostatistics is variability. So what is variability? So this word comes from the word varies, or which is differs or different, something like that. So variability refers to how spread occurs on scores or in a distribution. So variability entails the distribution of spread, the variances, the variables, the differences between scores. So that's variability. So most of the natural phenomena we study are variables both in space and time. So most of these vary. For example, your gold deposits, they will vary from one point to another, so that's a variable. So considering a topographic surface or underground water contamination, one can observe high variability within small distances. So that's an example of how we can encounter variability in real life. So variability is a result of natural process that it is deterministic. So we can determine this variability. Take note of this word, deterministic. So by the word deterministic, we mean that it is predictable. We can predict that, or it does not have uncertainty. Right, so the stochastic methods. So in probability theory, a stochastic process, or sometimes called a random process, it is a collection of random variables, and this is often used to represent evolution of some random values or systems over time. So a stochastic variable or a stochastic method is a collection of random variables. So if you collect those random variables, the random variables we talked about are the deterministic models. And then so from these deterministic models, if we include the probabilistic approach, which is if we include the uncertainty theory, we then come up with a stochastic model. I hope the next diagram will explain what I mean by a stochastic model. Right. So for example, a deterministic model, if you want to sketch or to plot the graph of y is equals to 5x plus 3. So the graph will look like this. So this is deterministic. You can actually, if you're looking at this graph, you can actually compute this equation of a line. You can actually compute this. You can actually determine the variability. How does x's vary with y? You can actually tell. It's clear. So this represents a deterministic model. And then for a probabilistic model, it has got two parts. It has got the deterministic model, which is 5x plus 1, and then the random noise. The random noise, that's your uncertainty, that's your probability part. So for a stochastic model, or for a stochastic method, you need to have a deterministic part and then the stochastic part. So as you're looking at this graph, you can see that there is and as x increases, there is also y also is increasing. So there is that deterministic relationship. However, there are also small variables or variations that exist within the model. These are the probabilistic, and we call this one a random noise. Thank you for listening. You can pause and go through this lecture, and also don't forget to read your lecture note. If you have got any questions, ask on the Google Classroom. Thank you for the lecture.